Next talk will be given by Stanley Kim. Stanley Kim is the CEO of Trick Play. Prior to Trick Play, he was with Samsung Electronics, McKinsey and Company, and Broad-Based Software. Today's talk is about outstanding UI and high-performance graphics. Let me introduce Mr. Stanley Kim.
저거는 노트요? 제 거요?
F5.
아, 저한테
F5 누르세요.
이거
그러니까 발표 전에 모든 두 가지가 있어요. 하나는 단순 슬라이드쇼고 하나는 편집 콘텐츠.
저한테 보내주신 게요?
됐어요?
이거 넥스트 백 그리고 이게 포인트 빨간 색깔 이거.
맞습니다. I wanted to start by just saying thank you to the hosts and the organizers and the sponsors. Having done these kinds of events before, I know how much hard work goes into making for a great event. So thank you for the opportunity and the invitation. I thought I'd start by just a quick introduction of myself. Prior to starting Trick Play, I spent about 6 years working at Samsung Electronics in the CTO group, as well as in the engineering group of the television business. And it was a phenomenal time to be involved in the television business. Samsung during that time went from not making money to making lots of money. It was a formational and kind of wonderful experience for me. So it's always a great pleasure to come back to Korea. Excluding my time at Samsung, as the introduction mentioned, I worked at McKinsey and Company here in Korea and had the opportunity to live here for a number of years. And then prior to that, I'd say out of the last 20 years, I've spent about 15 years living in Silicon Valley, living and working in Silicon Valley. The topic I wanted to talk today about is about graphics, and more specifically about embedded graphics. And the reason I wanted to focus on this area is really graphics is the core in terms of how a consumer experiences all of these wonderful products, whether they're set-top boxes connected to IPTV or satellite or cable, or whether they're televisions connected to broadcast sources of content, and so on. In terms of embedded, I also wanted to spend a little bit of time offering a little bit of an alternative view based on some experiences by what are iconic companies in the Valley. Traditionally, to design for TVs or to design for set-top boxes, you've had two traditional kinds of approaches. The first approach is native. So implementing UI, UX, or applications in C, C++, OpenGLES code. And this has one huge, great benefit, and that's it has the best performance you can obtain from any given embedded hardware device. The problem with native approaches is native approaches tend to be extremely resource intensive. You have to deal with low-level concepts that require a lot of time and effort. It also makes development, maintaining, extending, modifying a core application or UI much more difficult. So then the second primary approach for really utilizing graphics in embedded world has really been scripting kinds of approaches. And scripting in its own way has its merit. In particular, because of abstraction, you're able to utilize functions and classes and not have to deal with lower level concepts. So this makes the development relatively faster, less engineering, less design work, and it makes it also more extensible and easy to maintain over time. The big disadvantage about scripting approaches is the following. Scripting approaches have a terrible execution path. Terrible. Not bad, terrible. Typically, if you think of ActionScript or if you think of JavaScript, basically you have a scripting layer that is sitting on top of a virtual machine that needs to hit CPU and needs to hit CPU memory, then graphics memory, before actually being drawn on the screen by composite or by blitting. And so the advantages in terms of ease of use are undermined by this complicated execution path that doesn't allow you to have good performance. So a lot of people have historically said, well, this problem will be solved when the SoC in the set-top box is better, or when the SoC in the TV is better. But there's something very, very subtle and important to understand, which is no matter how good set-top box hardware gets, no matter how good TV hardware gets, it's always going to be behind smartphones, and it's always going to be behind tablets, and it's always going to be lower spec than PCs. So then the challenge is, with this cost-effective, very, very low spec compared to PC or compared to tablet or compared to the other kinds of devices, how do you have a great user experience? And I think historically people have said hardware is part of the problem, but I think one of the challenges that's one of the fundamental questions that our company has focused on over the last 3 years is we think that the problem is not hardware. No matter what the hardware is, it'll always be worse than a PC. It'll always be worse than some of the other devices that have faster refresh cycles, that sell for higher price points. And so our conclusion was that this problem can actually be solved through software architecture. Talk is a short talk, but it's really divided into 3 primary sections. One is really talking a little bit about some of the things that we're seeing today in Silicon Valley. And I chose 2 what I think are representative examples. The first example is Facebook talking about HTML5. Facebook is a wonderful company. And one of the things that's most extraordinary about Facebook is that they have extraordinary software talent. The average software engineer at Facebook is a very, very competent, very, very accomplished professional. And so if you look at the history of Facebook as a web company, a large and growing part of their business was driven by mobile. And in mobile, what they elected to do was they elected a HTML strategy, an HTML5 strategy. And HTML5 has the potential of having a number of benefits, including portability. So you develop something once and then you can use it on multiple devices, including having a wide base of professionals who already understand scripting technologies very, very well. But their conclusion earlier this year was choosing HTML5 as an approach for mobile devices was the single largest strategic mistake that they think they've made in their history. Let me repeat that. So HTML5 has a lot of potential. And I understand as a former engineer why you want to have one core code base and not fork that and have to do multiple developments. But a company that has extraordinary engineering talent made a decision, and they now think that this is probably one of the worst decisions that they've made in recent years. So that's a very, very profound message, and it's a message I think that hasn't really gotten a lot of attention here in Korea, and so I thought it would be a worthwhile example to share. I do think that for certain applications and for certain kinds of processes, HTML5 is ready today. But for some of the applications, if you think about the level of complexity, if you think about what they're trying to achieve, in particular related to performance, it's very, very difficult. The second example that I thought I would choose is another iconic Silicon Valley company, and it's Google. And Google had the idea for browser-based applications, including games, and they thought, boy, if we just optimize our version of Java Virtual Machine, if we utilize the full capabilities of things like OpenGLES, if we optimize the performance, we should be able to get what we want. And the conclusion that Google drew after this porting exercise, and there's a wonderful talk that's about an hour-long talk by the lead of the team, who basically said, it's not there yet. And one of the examples he gave, this is a very detailed, specific engineering kind of example, but it's a meaningful one because in particular for games, you care a lot about performance. And the example was to multiply a 2D matrix times a vector in JavaScript or HTML5, this requires 875 instructions. 875 instructions to do a multiplication of two tables, in essence. And so the question in my mind is really, when you're doing these kinds of multiplications, the CPU is a general purpose part. And really what you'd like to do is utilize the GPU, which is structured specifically to be able to do parallel processing and calculations. But when you have all of the baggage of a browser, no matter how much you optimize it, with the best, arguably some of the best engineers in the world, at a company whose core expertise is software and software only, it's a very, very challenging and may not actually be possible kind of work scope. I think that this will change in the future, but even if it changes in the future to the point where you can have performant HTML5, there'll always be a difference between PCs and mobile phones, on the one hand, which tend to get the best, most expensive specification of hardware, and on the other hand, lower cost, true consumer electronic devices like a set-top box that costs less than $100, or like a TV. And so those were two examples that I thought I'd start with. And the second thing that I thought I would do is, the second part is really to talk about what is possible today based on fully utilizing the GPU that exists today in modern SoCs and fully utilizing a software architecture that creates a very, very efficient execution path. Well, that's... Sorry. Sorry, guys.
Do you have a
USB에 저장
here?
저장되어 있어요.
파일을
네.
동영상이 안 됐다고 봐서 죄송합니다.
괜찮습니다. So I thought I'd take you through some, I apologize. I thought I'd take you through a couple of examples of work that we've done over the past year that shows what we consider modern, high performance kinds of UI, UX, or applications. And these are UI, UX applications that run today on every single major platform. So this kind of performance, so I talked a little bit, there are really two things that are driving this level of performance. One is really directly driving graphics. So not having a execution path that involves CPU, memory swaps, calculations, and then blitting or compositing on the screen. This is true OpenGLES style graphics. I think the one difference is OpenGLES, like C, is difficult to develop. So what we've done is we've built a C++ engine. That C++ engine binds directly to OpenGLES driver and directly drives graphics. In order to get the benefits of abstraction that allow you to develop this kind of application very, very quickly, what we've done is instead of choosing something that is a generic purpose virtual machine, generic purpose environment like JavaScript or ActionScript, what we've done is we've chosen something that architecturally is fundamentally built for embedded, and it's a unstructured, expressive, embedded optimized language called Lua. So at the topmost level, we use Lua to get the benefits of scripting. At the core, the application is executing at native quality speeds, because if you profile an application, the application is actually spending 97, 98% of its time running in C. And so we think this kind of approach is an interim approach that allows you to garner all of the benefits of native quality performance, that allows you to have the benefits of abstraction that you typically associate with scripting, but at the same time, run on existing devices today. We scrolled through it once, and these are just examples of work from the past year. But I think one thing that's important to notice is you should have beautiful experience as a customer. Whether it's a TV or a set-top box or a phone or a PC, you should be able to have a beautiful, graphical, interactive experience. I think the second thing is the core underpinning of what I like to call modern UI is you have to be able to do things like cover flow. You have to be able to have transparencies, animations, transitions. You have to be able to do all of these on the device that you have. It's one thing to have a very, very beautiful phone that retails for unsubsidized for $700 and be able to have a beautiful cover flow experience. But you ought to be able to have that because the chips that are in set-top boxes today and TVs today support this already today. So we've now done this and shown that this kind of software approach works on Samsung today, works on LG today, works on Broadcom, Trident. All of the major SoC manufacturers are now producing SoCs that have a GPU block, and that GPU block is wildly underutilized. It just sits there. Why? Because ActionScript and JavaScript are CPU intensive, not GPU intensive. So there's a portion of that SoC that's sitting there and it's doing almost nothing. So that's the core of our software approach. And what we're doing with this today is our core customers are really in the satellite and cable markets. These are customers who have typically greater than 10 million subscribers. So these are large companies. And what we're helping them to do is to give them Intel quality performance on embedded devices. If you think of a major pay TV operator, and you could include, for example, in the greater than 10 million subscriber category, that would basically be, there are probably about a dozen in the world, but it would include Comcast, Time Warner Cable, DirecTV, Dish. There are probably another half a dozen scattered throughout the world, UPC. And for these folks, CapEx per player per year just for customer premise equipment is about $4 billion a year. It's about a $3 to $4 billion a year problem. And one of the things that we're seeing is there is a lot of innovation. There is also a lot of complexity. But one thing that, as a core value proposition, we're trying to offer to these folks who care a lot about threats from iPads, threats from Apple devices, threats from other ways of getting to content and other alternative methods of content distribution, is that you should be able to have a beautiful experience for your consumers and subscribers, and you can do it today on very, very aggressively priced hardware. So I'll just go through a couple of last slides and skip through the ones that I've already done. Okay. So in terms of raw performance here, we are regularly on major hardware platforms seeing about 40, 50 times the performance of JavaScript, HTML5, or Flash. I think one thing that's important is Korea right now, there's a huge wave of activity around HTML5. I think the bad news is in the short term, in the next year or two, HTML5 performs even worse than Flash. Most of the manufacturers that are working with HTML5 right now have spent 2 to 3 years working on Flash platforms, and Stagecraft for embedded is something that Adobe no longer even supports, and that the major manufacturers have, I think, learned the hard way. It's very, very difficult to take something that was built originally for a PC and make it work in the embedded world. I think that there will be, over the next couple of years, a similar kind of learning process. But really trying to do, the one other alternative is to try and be able to do this in native code, and native code just takes too much effort. Even large companies with thousands of engineers will find that trying to make an entire on-screen display, trying to make an entire UI, trying to make all of the core standard apps in native code is 1,000 engineers, 2,000 engineers is not going to be sufficient. So I'd say the highlights really are, we believe we've achieved in the last 3 years the best performance in industry. The previous example that I just went through, this is on a Samsung chip, the core Samsung TV chip from about a year ago. We feel that we've had enough third parties, Broadcom, Trident, SoC vendors, verify that this is outstanding performance from their perspective, and they've not seen anything like it to date. I think the second thing is the point that I really care a lot about, which is you ought to be able to have a beautiful experience. It shouldn't be the case that only Apple devices or only Android devices are beautiful experience and the TV is a terrible experience. The content on TV is something very, very wonderful. I think a lot of the speakers today have talked about the Olympics and what a milestone that was. These are experiences that can bring people together and have a huge impact on the level of joy or enjoyment that you can have around live sports, that you can have around professionally produced content. But the graphics portion should also be beautiful. And there isn't any reason why that can't be done today. And then I think the last thing, these are businesses that typically, core consumer electronics companies typically run on profit margins of less than 10%. And they tend to be very, very cost efficient and very, very sensitive to price. This is something that adds no additional bill of materials. So there's no change to the hardware. There are no extra discrete components or things like that. This is zero additional BOM cost. I'll take a couple of minutes to just talk a little bit about some of the major trends that we're actively funding and pursuing as a company. I think the first one is ultra high definition graphics. So the transition from SD to ED to full HD in video took a long time. And part of the reason that it took a long time is there's a lot of existing equipment that needs to change in order to make that transition. So from special cameras to capture at higher resolution, special equipment to be able to encode, transmit, manage, distribute. We actually think that ultra high definition is going to be much, much faster in graphics than it will in video. Ultra high definition in graphics should be able to become a reality much, much quicker because there are no dependencies on broadcasters or content producers or capture devices. There isn't any infrastructure that needs to change. This is self-contained within the existing device. So our core thesis around that is we don't think that there's another company that can be able to do ultra-high definition graphics with transitions, with animations, with this level of performance in the world. And so this is an area where we think our architecture and our approach has a highly differentiated position in the marketplace. The second area that we're really spending a lot of time on is really the 10 million subscriber or greater. It's primarily satellite and cable. I would love to also find a hybrid IPTV satellite service, for example. There's one in Europe, there's one in Asia, to be able to work with. But really, what we're finding is the people who have the most customers see the value of this the most and actually can pay us the most. So it's a focus for us because there's a major opportunity there. And then the last area that we care a lot about is we care about multi-room support. So in a lot of homes, video does not get routed to just one device in one room, but in particular in the US and in Europe, multiple room support is very, very important. And in addition to being able to provide Intel quality experiences and graphics on embedded, we're also looking at very, very low cost clients and improving the performance of low cost clients so that in a second room, a third room, a fourth room, you can have a beautiful high quality HD graphics experience. The only other conclusions that I have are, I apologize again for the technical difficulties, and thank you for making it through the last session. I'm happy to take questions in Korean or in English.
Any questions? Okay, no questions. Thank you very much, Mr. Stanley.